Let's work through question number 14 in chapter 8. It says a simple random sample of 54 provided a sample mean of 22.5 and a sample standard deviation of 4.4. In this problem, we'll need to develop three different confidence intervals: a 90% confidence interval, 95% confidence interval, and a 99% confidence interval for the population mean. And then we take a step back and look at what happens to the margin of error and the confidence interval as our confidence level increases. So this first part, our 90% confidence interval. We have everything that was given to us over on the left side. We have our n, our x bar, and our s. So we have two different confidence interval formulas on our formula sheet. We have one that uses a z-score and one that uses a t-score. So if we can prove that we're able to use a z-score, then we go with that one. But here, none of our three proofs work out. We don't have sigma, and n is not greater than 100. So that means that we need to use the formula that has the t-score instead. So if we look through that formula and piece by piece, our x bar, that's our 22.5, our t-score for alpha over 2. So alpha in this problem is going to be 0.10. We get that by taking 1 minus our confidence level of 90%. But they want alpha over 2, so we write that down as well. Now our S, our sample standard deviation, that's our 4.4, over our sample size of 54. Then we get to our finite correction factor. We don't have a population size in this problem, and so since we don't have a big N, there's no way that we can use this finite correction factor, so we just don't even worry about that. Now we just start plugging in the pieces that we know. So we know it's 22.5 plus or minus the t-score of 0.05 times our standard error. Now, to find this t-score, we need to know a few things. We first need to know our degrees of freedom. So we get our degrees of freedom by taking our n minus 1. So our degrees of freedom will be 53. And then the other piece that we need when looking up this t-score is the area in the upper tail. So the area in the upper tail, that's just our 0.05. So when we're looking in our t-score chart, along the left side will be your degrees of freedom. So we find 53. Up along the top will be your area in the upper tail. So when we look up our degrees of freedom and our 0.05, we find that our t-score comes out to be 1.674. We'll multiply that by our standard error to find that our margin of error becomes 1.002. So now the last step here for the confidence interval is to take our x bar, 22.5, and add and subtract 1.002. So we are 90% confident that the population mean will be somewhere between 21.498 and 23.502. So now if we need to develop a 95% confidence interval, the majority of this problem is going to look the same. We use the same formula, but what changes here is our alpha. Instead of alpha being 0.10 like in the last problem, when we take 1 minus our confidence level here, we get 0.05. So alpha divided by 2 is 0.025. So now we plug in everything that we need, and we look for our t-score. Once again, since our sample size did not change, our degrees of freedom will be 53. So we look up our degrees of freedom of 53, and the area in our upper tail of 0.025, and our t-score will be 2.006. So now to find our margin of error, we need to take our t-score and multiply it by our standard error. When we do that, we get 1.201. So now we can add and subtract that from our sample mean to find our confidence interval of 21.299 to 23.701. Now a 99% confidence interval. Once again, we'll be using the same formula. The piece that changes is our alpha. Now if we take 1 minus our confidence level, we get 0.01. That's our alpha. We need alpha divided by 2, so this is 0.005. So we plug in everything that we know right now into our confidence interval formula. When we look up our t-score, we need to know our degrees of freedom. Our degrees of freedom will still be 53. And for our t-score, we need to make sure that when we look at the area in the upper tail, we're looking at 0.005. So we find our t-score to be 2.672. We multiply that by our standard error to get our margin of error. And our margin of error rounds to 1.600. So now we take our sample mean of that 22.5, add and subtract our margin of error, 1.6, and we are 99% confident that the population mean will be between 20.9 and 24.1. So now the last part of this problem. It wants to know what happens to the margin of error and the confidence interval as the confidence level is increased. So this table shows our margin of errors and confidence intervals that we have solved for in this problem. And you can notice a pattern that as the confidence level increases, our margin of error increases, which then makes the confidence interval wider.